I'll just give 1 minute for us to start joining. So just a minute and I'll begin. So today is going to be about reading data on Solana. So what we are going to do today is we have gone through writing data on the Solana network. Sorry, talk. We've gone through reading data on the Solana network. Now, what we'll go into is how to actually write data on Solana. So, writing data, what we'll be doing exactly, that is the writing on Solana. So, please, if you can see my screen that I shared now, just indicate for me. Okay, okay. Let me share again. Can you see it now? Okay, all right. That's good. So let's start now. Can we? Because even though others have not joined, they can always come back and see the recorded video. So what we're going to be doing today is we'll be going is reading data. We'll be going through reading data on Solana. So reading, we have several functions when it comes to reading data on Solana. After we just went through writing on Solana. Now sorry, we just finished reading on Solana, which we viewed the balance of a wallet. So today is going to be about writing on Solana, which we actually as developers write data on the Solana network. So we will do that by performing a transaction. You understand? Now, when it comes to writing data on Solana, there are several functions or several activities which you can carry out. So what we are basically going to be doing is sending soul. We'll be sending soul from an account or an address to another account or to another address. We are going to paste the address on our command line. We'll paste the address where we want to send the soul to on our command line. Then we run the command, and the transaction which we initiated in our code, the transaction we initiated in our code is going to work, and the amount of soul we um, we wrote in the code will be sent to that address which we pasted, or which we copy and pasted on the command line in order to send soul to that particular account. So let's go to number three. So let's go to our code. So this is our previous code. This is the previous code we had. So this code is the code that reads data on Solana, which we used to view the balance. We used to view the balance of the wallet that this particular address represents. So when we let me come over to the terminal. So or let me run the terminal here directly from the code with control on this squiggle, and let me go here. So either you do the short form, or you can come here terminal, then click new terminal here. So in this our cryptography directory, so The file that is used to read data, which contains this code, is the one called this read.ts. So if I run it now, I will say npx ps run read.ts. So so we can see the balance of this particular wallet. Or let me open the this thing. Let me open the wallet where I got the address from. So this address is on testnet. Sorry, it's on devnet mode, and it's so devnet. This is the address. So it is farm wallet. You can see the balance here, the devnet tokens here, of which I will show us how to get devnet tokens from the Solana devnet API, or the faucet, the faucet which is made to where developers can get devnet tokens for deploying of contracts. So this is the balance here in Lamports. This is the balance. So there's a little bit of a problem here. The balance is in Lamports. So if you want to view it in Sol, in actual Sol, so we are going to so this Lamports per Sol, this function we called this function we imported, we imported from the Solana Web3.js. So we are going to use it here. So I will create a const. I will call it, since this const here is balance. So automatically the balance is automatically this balance here, the balance is in Lamports. So I want to create a balance that is in Sol. I'll call this constant balance in Sol, and I'll set it equal to balance now divide by the function Lamports per Sol. You get it now? Then I will so I'll console log. So I'll do console dot log the balance of this wallet in Sol is balance in Sol. So this balance in Sol here. So when I come to my terminal and run code npx es1 read.ts. So now we can see the balance in LAN ports and also balance in Sol. So that's that about um, reading data in Solana. So in the comments, if you have any question, just type your question. Let me see here. Any question about reading data on Solana or generating a key pair or what we have done so far before we go into actually writing on Solana. So in the absence of no question, I know we have few in the meeting right now. If you are following, just type I am following, please. Just let me type I am following if you are following so far. Or if you followed with these few things I just did now. Alright, alright. So okay, only one person. Favor, what's up? So the next thing we'll be going into now is is going to be writing data on the Solana network. So, so here I created a file and I call the file write.ts. So we have three files here. The first file is just generating a key pair where we imported the key pair function from the Solana web3.js. Then the next one is to read data on Solana, where the function we performed is to view the balance of a Solana. Sorry, the balance of a Solana wallet actually. Then the next is write.ts. So so now just talking about this reading data on Solana. So you can just grab anybody's wallet you can just grab anybody's wallet address and put it here. Then you put it here where we created this new instance of the function pub key. You put any wallet there, then if you run the code, if you run the code, you are going to see anybody's balance. And there are also other functions you can perform which will enable you to view things or view other details of that particular wallet, where you can even see things that you are not even supposed to see. So that being said, let's move straight to writing on Solana, where I created this file, called write.ts. So the first thing we will do, just like the reading file, we are going to import some functions. So I'll say import. We are going to import connection, another going to be importing will be the transaction, just as most of the functions we imported here. Okay, we didn't import transaction here, so we are going to be importing transaction also, because basically, or let me say, yeah, basically what we are going to be doing here is to send some amount of SOL from a particular wallet address to another wallet address. So it's going to be a transaction. So that's why this transaction function being initialized. Then we are going to import what we call system program. So this system program is what enable us, normally anything we do on Solana or on blockchain, in this context Solana, and whatever we do is a transaction. So it just depends on what type of transaction and the um the action you choose to perform in the context of that particular type of transaction you are running. So this system program is the function that will enable us specify the transaction we want to carry out. So after this system program, we are going to import another function called send and farm transaction. send and confirm transaction. Then we will import public key as well. Now we have imported 1, 3, 4, 5, five functions from this Solana Web3 JS um, library or SDK. Is basically a library in a programming context. So now, having imported these things, now we are going to be using an env file, but we'll get to that later. So before we get to writing, there's something I would like to talk about, which is transactions. So like I said, anything we'll be doing on the Solana network is a transaction. So let me just review the lecture slides. Let's see the transaction part. Writing on Solana. Now this is transactions in Solana. So all modifications to on-chain data happen through transactions. Transactions are mostly a set of instructions that invoke Solana programs. Transactions are atomic, meaning they can either succeed or they can fail. So if all the instructions have been executed properly or fail, if all the instructions have been executed properly, that's when the success. If not, the transaction will fail if peradventure or by any means there is an error. So I think there will be an assignment for us today. So let me go back to the code. So now, having imported having imported this set of functions, a.env will import a.env. So this dot let me I will explain what it is about and what actually it does in this particular context. So .env, .env/config. So this .env basically is a function that gets a key pair from an environment, in the sense that it doesn't actually connect to the Solana network digitally. It's just a that we can create locally here. So it just connect to it and perform whatever we specify it to perform. So in order to get this env up and running, you need to come to the terminal here. There's something you are going to need to install, which is Solana Developers Helpers. So I'll do npm install at Solana Developers slash helpers. Even though I've installed it already, but just to demonstrate. Now look, one side. So you have to run this command npm install at Solana Developers slash helpers. Let me type it in the chat here. So that's the command install you will use to install these Solana developer helpers to be able to get because these are just some SDKs or APIs that is made by the Solana network a bit easier. So you can use it to like connect to local environment files. See, is it .env or dot? It is .env, not mn .env slash config. So haven't installed that one function. So we import get key pair from environments. So it's just like I said, this or let me copy this thing and put in the chat if you want to import it here. So for Mohammed Farid who asked, I've just dropped it there. So import get key pair from environment Solana developers help us. Now this import.env is a file we are going it's an env file we are going to be creating here that will hold our secret key because for this transaction to go through, I will need my secret key to initiate the transaction. So this get key pair, how am I initiating the transaction? I'm going to be getting a key pair from my environment transaction to go through. So having done that, I got this get key pair from environment from this Solana developers helpers library that I just talked about. So what we'll be doing is that when we want to execute this function, after writing like npm ES run, then the name of the file we want to execute, pasting an address, the address of the wallet we want to send SOL to. Do you get? You understand? If you have any confusion, just type it in the comment. Let me say, for example, we'll do this npx. We'll create a constant or a variable of the person we are going to be sending that SOL to. Because all these things we are going to be like initiating and accessing them on the command line. So I'll say const what will I name it? I'll name it supplied. So I'll name it supplied to pub key because we are actually supplying some amount of SOL to that public key. So I will set it or I will assign this constant to a process is how would I explain this? A process is just like it's a function that initiates or initializes or and any additional command we are going to be writing on this command line. Like when you initiate a process, you have to like pass in something for it to perform. You have to give it an argument or something like you can see there's add listener, there's abort. These are several um, methods or functions that can be passed to this process to you. So this agree is an argument. So an index of 2. Now, why is it taking an index of 2? Or what does this thing actually mean? This thing means that we are going to pass in, or when we run dance here, and this constant represents the address of the person's wallet we are going to be sending that amount of SOL to, sorting it into the command line. So it is a command line method. So why the index is 2 is because once you use this arg method or this arg function, there are this arg normally or ideally this arg is an array of several indexes, of which the first index is node. Because whenever you are this arg, basically what it does is it handles um command line inputs that runs on node. And remember, we installed npm, which we used to be like installing all the stuff you are doing. So it is running on node. And so um the first index is the file path, path, the file path that leads to this. Then the second, that's the second index, node itself. Then the third we put in by ourselves. So, and in programming, ideally programming starts counting from 0, 1, 2, like that. It starts counting from 0 and not from 1. That's why this number 2 represents the third particular method. So what it does is that if you run this command with npx esrun, and then you are supposed to put in an address, but you didn't put an address or anything, it is just going to set to null. So apply to okay. So that is that. So this error, I'm going to deal with it in a minute. So let me clear this out. Const supplied to pub key equal to v2 set to null. So that's that. So now the next the next thing we are going to do is we are just going to create a statement, an if statement that we hold, or that we check to see if when this file or this code is being run, an address is actually um, imputed into it. You get? So, of which we all know that this supply to pub key is the constant that is holding that particular address. If not, I'll be using, sorry, the not operator. So what this statement will say, if um there is nothing passed into this particular is passing something or put in an address. So I'll say if not, meaning if supply to pub key wasn't gotten, if not supply to pub key, console log say please provide a public key to send so to. Then this process that was initialized here, that was started here, I'm going to end the process here because that's where its work stops. So process dot exit, passing one, and that's it. Let's do some console log have loaded a key pair. We loaded a key pair. Abi? Or no, we only created a public key. We only like initialized a constant to hold our public key, to hold the receiver's public key. So let me do a const send, I'll call it sender key pair. Then I'll set it to, now I will use this get key pair from environment. This get key pair from environment function, that's where I will use it because I'm going to be, me writing this code, I'm the one sending the transaction, initializing the transaction. I'm the one sending the soul. So I will be bringing my own key pair, my secret key, into this code. So I will say get key pair from environment. Now get key pair from environment. Meaning what this means is that it's going to get my key pair from this code environment. So that's where the env file that I'm going to create will come into play. So I'll create an env file because ideally I'm not supposed to, it is supposed to be my secret key. Let me just, I'll name it just .env. Good. So it is supposed to be my secret key, which I'm not supposed to share with anybody. So that's why I cannot put it in this particular code file. I have to create a separate file. So this env file is created, is made specially to hold this um, secret key. So let me go to my browser to get my secret key. So I will go to my Phantom Wallet extension. Let it open. So here we go. So I'll come to settings, security and privacy. No, I go to my bootcamp. So this is my Soulflare wallet. We go to the settings. From settings here, I'll go to general, network devnet. Send approvals. Um, address. I'm trying to get my secret key from this wallet. So settings. So this is it. Show secret key. Show secret phrase. So ideally, your secret phrase is supposed to be for you. You are not supposed to share it with anybody, and you are not supposed to keep it secret. So just for the purpose of illustration for this tutorial, I created this account. This wallet actually never going to put any real money in it. So it's just for illustration purposes. So it will prompt you to enter your password. So I'll enter the password here. So this is it. I will not secret phrase with anyone, including Phantom, the people that um, made the wallet. This is not the seed phrase I'm looking for. Show private key. Thank you. It's the private key. You know. So this is the private key for this devnet. I will just copy it and click done. So after copying it, I'll go back to my .env file. I'll just make a variable called secret key and paste it there. So that's it. I'll save it, then come back here. So I'll say dot. Secret key. Actually, I'm supposed to wrap this inside. So what I just did is that this get key pair from environment is an object function or a class function from this um, import I made here. I imported it from this Solana developers helpers. So I brought it here. Then since it's a function, I passed in this secret key as an argument to that function. So I will do a console log. So console log supplied say supplied to this public key. Then we put in this variable or this constant. So it becomes supplied to pub key. So let me run this command, yes, and see what this is going to give us so far. So I'll clear this first. I'll do npx es run write dot ts. So you can see it says please provide a public key to send so to, which is this particular um, message I sent here, because I said if a public key is not passed in here, console log this particular message. Please provide a public key to send so to. So what I will do, let me pass in a public key npx es run write dot ts. So let me go to my Soulflare wallet. So all this money you see, they are not real money. They are DevNet tokens, of which I will be talking. And even if I don't talk about them now, maybe our next class I'll just brief us. So I switch to DevNet. I'll come here and copy the address. I've copied the address, which is the public key. Then I'll paste it here. So let's see what's wrong. Write.ts. Paste again. So you can see supplied to this public key. Supplied. I think I made a mistake here. It's supposed to be. Let me not use this template literal. Supply to pub key. To this public key. Supplied to pub key. Yes. So let me redo it again. Npx esrun write dot ts pastes. So you can see the code is working. Say supplied to this public key, the public key. So this is the public key that we actually passed it in. So we actually passed in here. So we can see that our code is working so far. So let's go on. This is distracted. My screen is not showing Mohammed Farid. Let me check. Okay, let me stop sharing. Let me share the screen again. So Mohammed, can you see the screen now? Or something? Let me type in the chat. Okay, now you can see. Thank you. So, so have you following so far? If you have been following, just type in "I am following." Please, if you are following so far, just say "I am following" before I continue, because I want to like see how I can carry everybody along as we move. So please type "I am following" if you are actually following the class. Now let me go on. You can always come back to this channel and check for the video. So, um, next public key we are going to be um, um, passing here to send soul to. So there's another. What this dot git ignore does is that to ignore that my secret key in here. Do you understand? The secret key that I passed in here dot git ignore. If I push or send this code to GitHub or any version control system for developers, it has my secret key. But anybody, even if I give you access to view my code, or maybe I make my code or my project open source for anybody to contribute to or see it or use it, you won't get to see my secret key that I imported there. So that's the job of this dot git ignore. So I have to give it like I have to show it the file. I'll just type in the dot env and that's all. The dot env, because it is this dot env that I actually stored my secret key. Then I will do a const also. So this const will be a const that will be like that will use this public key, because this transaction is it's a transaction that sends a token or sends soul to a public key. That's why this public key was imported. And the public key we are actually sending to is this constant I created here, to be passed in when we run the code. So I will just initialize instance, a new instance of this public key function. This public key function is an object actually, because it has other functions embedded in it. The function. So now this code or TypeScript has now known based on everything we have imported here. It has known the key. What we are sending it, we cannot just send any number or anything, or maybe just write. It has to be a we are going to create. Initializes a connection. So we'll just call it connection. The connection, this connection function, which connects to the Solana network. That's what the function does. So we initialize a new instance of the connection object function. And now the thing is, what is it connecting to? It is connecting to Solana DevNet. To the Solana DevNet is where is the API that we are going to be using to make this connect. I'll say https slash slash API. Do you understand? Certainty that a transaction will go through by the nodes operating on the Solana network. They validate. So smart contracts we create and send don't just get confirmed like that. It has to be validated by some set of computers running it, which are called nodes. So the balance between it being confirmed by people and the certainty that the transaction will go through is what we call a commit level in connecting to the network. So there are several commit levels, as you can see. There is confirmed, there is finalized, there is max, processed, recent root, single gossip. So you can make your research and find out what all these other ones mean. So we are going to be making use of the confirmed here, a commit level of confirmed, which this confirmed means that majority, if not all, of the node operators have confirmed this transaction, and the transaction has a high certainty of being successful. That's what this confirmed is doing here. Do you understand? Now, so far before I go on, does anybody have any question? Let me move to the chats. Please, if you have any question or any confusion, just type in the comments and ask. Or before I continue, or let me just go ahead and continue. So I will just do a console log to confirm that everything I've done. So what I have done, what have I done? I have created a constant to hold the senders, or sorry, the receivers or the recipient's public key. The sender's key pair. I have also created a constant that will hold it and an env file that will keep it safe. So even if you see the secret key here, I'm not going to put real money in the wallet anyways. So I've also created a constant that will constant of variable to be an actual public key in the form of this alphanumeric text here. Then I've also created a connection to connect this transaction to the Solana network or to the Solana blockchain. So let me just console log a confirmation message. Let me remove this terminal here. Console. So I'll say loaded our own key pair. the destination, the destination public key, and we also connected to the Solana network. So you can see this is just a confirmation message for what transaction. We have initialized a transaction now with this thing we just did. Do it as sending one soul. So one soul is equivalent to 1 billion lampots. 6, 7, 8, 9. So that's 9 zeros there. 1, 2, 3, 4, 5, 6, 9. So I've set the amount of lampots to send. Then I'll send. So this um constant I'm doing now, call it send soul instruction, is going to be the constant that will initialize this function here, this system program, because this system program, we said we are doing a transaction, but what exactly is the transaction that we are going to be initializing? You get? So that's where this system program comes in. It gives us, or it enables us, specify the particular transaction we want to carry out on the network here. So I'll call this constant send soul instruction, and I'll set it to this system program that I just talked about. System program. Then I'll do dot transfer, because system program, you are going to pass in that thing. So what we want to do is just to make a transfer. So that's why we are going to be using the transfer, this system program. So now we are going to specify the, now inside here, what we are going to do is specify how we are going to make this transfer. First, we specify that we are going to um, make a transaction. We give it an instruction, and the instruction says to transfer. Now we are going to like specify what and what would the transfer involve. So it's going to be, this is an object actually. So it's going to be from this, from pub key is a keyword. We are sending from a public key. This is an object, object in JavaScript, which has key value pairs like that. So that's what this one is. This is a key, which is a function of its on its own. We'll send, we'll specify the constants or the variables. Since we are, then we'll say to pub key, because we are sending from a public key to another public key. Then next we say lamports, because it's lamports we are sending. So this constant here, lamports to send, is the constant or the variable that carries the amount of lamports that we are going to be sending in order to make this transaction go through. So we'll just put a comma, then here our semicolon. Now the transaction, remember this transaction we initiated here, you get this transaction function. So we'll pass in, say, transaction dot add. This add is another keyword to add this send soul instruction. This send soul instruction is what initializes the whole process of the transaction that we are going to be carrying. So this transaction um, method we made here, we are just going to add this send soul instruction into it. Send soul instruction. Then next, so now for every transaction that goes through in the Solana network, there's what is called is a transaction signature. You get, now we have done everything we need to do. So after a transaction is done, a transaction signature, what is called a transaction signature for every transaction is going to be generated. So we want to see the transaction signature of this particular transaction. So we are going to create a constant that will hold that transaction signature for we to see. You understand? Now, blockchain normally, transparency is a feature of blockchains. Now, every transaction has a transaction hash. You are going to see every details of that transaction, generate a transaction signature. So in these transactions, the transactions are atomic, meaning they either succeed if all instructions have been executed properly, fail if there is an error. So there are chances that transaction can succeed or fail. That's the work of awaiting queue to handle the responses. Say await, then send and confirm transaction. This is where this particular function be imported gets to work. That's the role this particular instruction or this particular function is playing now. Send and confirm transaction. So it just handles the request. It handles the query, gives in a result whether the transaction is successful or not. So send and confirm transaction. Then we pass in everything we have been doing, a connection, our connection variable or our connection constant, our transaction, we pass it in also. Then we put this our sender key pair. It's our sender key pair that initializes this transaction. So it comes in as an array because there can be several key pairs that can initialize a particular transaction. So in this case, it's just one key pair. So since why it's coming in an array is because this thing can be multiple. There can be other stuffs or other key pairs or secret key or sorry key pairs that can be initializing a particular transaction. So in this case, it's just one. So that's why, because it can be of multiple values, that's why it comes in the form of an array. So we'll just put in a comma, make it here, put our semicolon, then do our final console log, console.log So say finished because everything is finished here. So we see sent. Um, Let me do a template literal for this one. Mm, So finished sent sent this lamp sent to the address to copy. Let's put a full stop. Yeah. So what this thing says is finished. I use the template literal. It's just template literal or is it string literal? One of those is a way of concatenating strings and variables instead of using all those plus signs. So you can just join them together in one single string quote. So let me come to our let me come to our terminal here and run the code. So see, let me clear. So I say npx es run write dot c. So remember we have to put in a public key which soul will be sent to that public key. So I'll come here. So let me use this Soulflare wallet here. Let it load. This wallet it takes time to load at most at times. Let me show the phantom. I wish somebody would send me a wallet address here. I wish someone would send me a wallet address here. I'm supposed to see my soul balance here, but it's not showing. I don't know. So I will put um, let me copy my wallet address here. So I'll copy my address. Actually, what I wanted to do, because it was this same wallet I used to initialize that transaction. So it was supposed to send Soul to this particular address, but I need just like another address so that I will paste it here and run the code to send Soul to that other address. So let's see. So you see the message it gives finished. Sent 1 billion lampots to address so. So let me open up and see what happens. You see the account balance was 14 devnet so, but because it is this same wallet I used, so nothing changes, nothing changed. So in our next class tomorrow, I will get another um, wallet address to send that amount of soul, to send soul to, so that we can see what this actually does. So that's it today. Call it a night. So I'll see you guys tomorrow, 8:30 p.m. Bye. Thank you.